Okay, so we are going to look at FLE 135 and FBF.2, where we're going to identify, interpret, and compare linear and exponential functions. But looking at active questions 7, 8, 11, and 29 from the 2018 South Carolina released Math 1 EOC. So beginning with 7, a club began with 3 members. Each month, each member brought 1 new member. Which function can be used to determine the number of members X months after the club began? Well, first of all, we need to know the initial value, and that initial value is going to be 3. Each month, each member bought 1 new member. That means it's doubling. And because I know that everything is doubling, that means I'm going to use an exponential function. So A and B are no longer options. And with my initial value being 3, I know that my formula for an exponential equation is A, or our initial value, times the rate of change, times our rate, to the x being time exponent. So A times B to the x. So initial 3, B being doubling, and some time span of x. That means our answer choice is going to be D. For 8, every 10 years, the census counts how many people are living in every town in the U.S. The 2010 census showed that 1,000 people were living in Appleville and 4,000 people were living in Bridgetown. So these are going to be our initial values. Then we have the population of Appleville is predicted to double every 10 years. Well, doubling means that we're going to have an exponential function. So following the same form from up here, A times B to the x, our A value or initial for Appleville is going to be 1,000. Our B, because it's doubling, is going to be 2. But the time span is going to be x divided by 10 because it's per 10 years, per decade. All right, so then that's one equation. And then our second equation, the population of Bridgetown is predicted to increase by 1,000 every 10 years. So our initial value we said for Bridgetown was 4,000. So 4,000, but it's increasing by 1,000 every 10 years. So this is actually linear. So it's 4,000 plus 1,000 times x divided by 10. Because again, it's per 10 years. So in Desmos, what I'm going to type in is Y1. We're going to call Y1 Appleville. So let's go ahead and denote which is which. And we're going to call Bridgetown Y2. Okay, and Desmos, just like our handheld calculator, will give us a table of values if we'd like. So here we go. We're going to type in Y1 is equal to 1,000 times 2. And to get the exponents, we can just choose this one, and then we're going to edit that to be x divided by 10. All right, so there we have it. And then for Y2, which is going to represent Bridgetown, Y subset 2, that's going to be equal to our initial value of 4,000 plus the growth rate of 1,000 per 10 years. And because we don't know how much time, it's x years divided by 10. All right, so here is that part. Oh, I totally erased that. My bad. Y2 equals, we'll do it again, 4,000 plus 1,000 times x divided by 10. Okay, maybe my sausage fingers will not. Oh, I keep doing it. I don't understand that. I'll get that fixed and be right back with you guys. Okay, so here are my equations. Finally, my sausage fingers quit that. And I'm just going to enter table by clicking plus table. Okay, my x values, I'm going to take away x of 3 and y of 3. Okay, and I'm going to type in y of 1 and y of 2. Now, it's going to give me a little danger symbol here, but that's okay because we're going to fix that. And this is how. So I'm going to be comparing Y1 and Y2 to figure out when Appleville, which is our Y1, when that population will be larger than Bridgetown's. And remember, this is every 10 years, so I'm actually going to use a count of x by 10. So the original x is going to be, let's see, that's 2010, right? So 2010 is our first year, that's 0. Our initial, and we see that we have 1,000 for Appleville, which is exactly what it says, 4,000 for Bridgetown, exactly what it says. 10 years later, that's going to be 2020, okay? Then we have need to make that a little bit bigger. Let's close that. Okay, then we have 20 years later, so 2010, 2020, 2030. Okay, we have 4,000, 6,000, so still not. Let's go one more. So 30 years after our initial of 2010 would be 2040. And in this case, Y1, which is Appleville, has outpaced Y2, which is Bridgetown. So in this case, that's going to be the year 2040, because we started with year 2010 at 0, and we added 30 years, so 2010 plus 30 is 2040. All right, so the next question that we look at is going to be 11. So let me go ahead and flip my screen there, and it says this. Maybe, give me one moment, make that a little bit bigger. All right, so it says, which choice could be modeled by a linear function? So the amount of money Y in an account after X years earning 4% interest compounded annually. B, the monthly cost Y to use a cell phone for X minutes at a rate of 4 cents per minute. C, the height Y of the ball after bouncing X times if each bounce reaches 2/3 the previous height. D, the amount Y of radioactive material remaining after X years when decay occurs at a rate of 30% each year. All right, well, first of all, I'm going to be looking for things that exclude it being linear. All right, so the first thing, it says the amount of money in an account after X years earning 4% interest compounded annually. Okay, so interest compounding annually is automatically going to be something that is exponential. The monthly cost Y, okay, let's write it, to use a cell phone for X minutes at a rate of 4 cents per minute, so 4X, well, that is linear, so that's an option. The height Y of a ball after bouncing X times if each bounce reaches 2/3 the previous height, so Y is equal to, well, I don't even know how to describe that one exactly, except that if you were to draw the graph, you would see that it does a number like this, which obviously is not linear, so can't be a choice. D, the amount Y of radioactive material remaining after X years when decay occurs at a rate of 30% each year. Well, decay or growth is always going to be exponential, so that means that B is our answer choice. All right, the last question we look at is 29. So 29, it'll take me a second to get there, guys. My apologies. All right, so for this, it says we were going to select each situation that can be modeled by a linear function. So please know that we're always going to have to write those in order to determine which it is. So we know that Y equals mx plus b is what we need to create if it's linear, so Y equals mx plus b. All right, so a taxi charges an initial fee of $2 and $1.50 per each additional mile. So what is the B value? Well, that's 2, and the additional mile is 150 X. So would this be linear? Yes, it would be. For the second one, the population in town increases by 15% each year. Well, increasing by 1% each year is going to be exponential, so no. An airplane flying at an altitude of 33,000 feet descends at a rate of 20 feet per minute. Well, the descent at 20 feet per minute is 20x, and it started, negative 20x plus 33,000. So yes, that's going to be linear. A pizza restaurant charges $5.50 per pizza and 50 cents for each additional topping. Well, that's an initial value of B of $5.50 and 0.5x for each topping. So yes, linear. And lastly, a cell doubles in size every 3 hours. So if a cell doubled, that's going to be 2 every 3 hours. So that'd be 2 to the x over 3 to figure out its like number at some point, or amount of cells at some point. So that is going to be exponential since it's doubling. So our answer choices would be A, C, and D.